Hello everyone, welcome to our mini project presentation titled Network Infrastructure Proposal for BITS-16 Syria Barat. My name is Kitigan Balu and I will presenting together with my teammates Ugahnesh Moorthy, Parthiban Subramaniam and Madhanavilashan Ganapathy. Let's get start the presentation. Now I'm going to talk about the project overview. The main goal of our project is to design, simulate, and configure functional network for a company with three locations: the HQ in Shalam, a branch in Kulim, and another in Skudai. We implement this using packet tracer with technologies including router, switch, wireless access point, and variable length subnet masking or VLSM. The network is designed to allow centralized internet access and clear departmental segmentation. Now I'm going to talk about the building layout and departments. The HQ has four floors. The first floor is for the technical department with four wire PC. The second floor is management, which has a mix of wire and wireless PC and laptops. The third floor is a server room with four servers, and the fourth floor is house the sales and marketing team with 10 wireless devices. The cooling branch has two single store house. House A is used by the service department and House B is a staff hostel. Skudai branch is a two-store building with a service department on the ground floor and hostel on the first floor.
Next, I'll talk about network topology. So all N devices connect to access switches, which then route to a central HQ switch. Everything is then routed to a HQ router, which then is the network's core. So the HQ router connects to two branch routers, BR1 and ER2, via dedicated WAN lines, allowing for complete inter-branch communication. So this architecture guarantees that the data flow reliably and securely between the headquarters and both branches. So each branch has its own router, access point, and switches to manage local traffic and wireless communication. The network also links to a web hosting server located outside of the LAN, providing external access to hosted services. Well, overall, this architecture provides scalability, centralized routing, and complete connection across all locations while clearly distinguishing between local and distance traffic.
So now move on to VLSM. So we apply variable length supplement masking, which is VLSM, to allocate IP address efficiently. The HQ was assigned the IP address, which is 192.168.6.64/26 block, which gives us 62 usable IP address. So this is enough for all departments there. So for the branches, share 10.0.0.0/23 block, which provides 510 usable IP address and is subdivided into smaller subnet according to the number of devices needed. Okay, now let's look at the detailed VLSM allocation that we use to assign IP address efficiently across the network. So we started by assigning the headquarters, which is Shala, a dedicated subnet, which is 192.168.6.64/26, which provides 62 usable IP address. So this is enough for all departments allocated across its four floors. So for the branches, we used the 10.0.0.0/23 block, which give us over 500 usable IP address. This range was then broken down into smaller subnet using VLSM based on the actual numbers of devices required. For example, the Skudai branch first floor needed 12 IP address, so we assigned it to /28 subnet, which gives us 14 usable addresses. So its usable IP range is from 10.0.0.1 to 10.14. The Skudai ground floor only needed 8 IP address, so we used a smaller subnet, which is /29, giving exactly 6 usable addresses, which is just enough for the branch. It uses 10.70 to 10.22. Similarly, Coulomb House B and House A each use /29 subnet to cover 6 to 8 devices with minimal IP wastage. By assigning each subnet only what it needs, we conserve IP address and make the network scalable for future addiction. This is the main advantage of using VLSM in our network design.
So here we have one wire PC static IP with success ping, and the second one wireless PC DHCP configure via access point. That will be router LAN interface configure, and lastly access point where SSID sent DHCP relay enable. So let's go see the topology. So from here we have topology where on the left side we have headquarter of Salam. It's contain 4 floors, which is first floor technical department, second floor management department, third floor server farm, and lastly fourth floor sales and marketing. On the right side we have two branch, which is branch one Kulim and branch two Skoda. So here branch Kulim we have two house A service department and house B staff hostel. So firstly, I show the successful connectivity between second floor and branch one. Being 10.0.0.2. So as you can see, it shows connectivity successful between second floor management department to branch school in house A service department. And then moving on next, I will connect between second floor and first floor. So let's say first floor IP address is 192.168.6.66. So as you can see, the connectivity between the first floor and second floor is successful connected. So now I will show the website 111.11.32.33.2. So here we can see the congratulations, your team has implemented effective device and network configuration settings, and it has thumbs up. Thank you.
In conclusion, we successfully built a stable, scalable, and fully functional network for BITS-16 Berhad. So, using VLSM, we ensured efficient IP distribution, and all departments and sites can now communicate effectively. So, in the future, this setup can be enhanced with VLAN's firewall policies and cloud service integration. So, thank you for watching our presentation. Bye.